All right, so welcome to the new reality, guys. Here we are. I'm gonna have to start teaching this way until we get to see each other face to face in class again. So I'll be posting these for each lesson. Hopefully you're going to be diligent enough to actually come, search them out, and use them and do the assignments. It's up to you guys. I'm going to do my part, try to help you out. You got to do your parts. So what we're looking at for this new unit, Chapter 3, Factors and Products, basically it's just a different name for all the polynomials. And that's what we're going to be looking at, is working with polynomials, what you did a little bit back in grade 9, and now we're going to just build on that. A little bit of review stuff, a little bit of new stuff. But to start with, factors and products today, we're going to work with something called factors and multiples, a little bit of review, and process. And I think we might have even looked at this a little bit at the start of the year in the 10.3. We'll find out as we go. First things first, though, a factor is a number that we multiply. So if I had the equation 2 times 3 equals 6, the factors would be 2 and 3. Numbers that we actually multiply. A multiple, in this case, multiples are products of a certain number. So if I said, as an example, let's again use the 3. Multiples of 3. Well, these are all the numbers that we get when 3 is one of the factors. So 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. 3 times 4 is 12. And we could keep this going on. So the next possibility, 15, 18, 21, 24, 27, and we could keep going. These are the multiples of 3 because they're the values that are the products when I use 3 as one of the factors. 3 times 1, 3 times 2, 3 times 3, 3 times 4. So 2 terms we're going to use a lot of over the next little while. But with that being said, we now have the process prime factorization. Well, prime factorization is when we write a number as factors. But all the factors have to be not any factors, factors that are prime. So prime factors are numbers such as 3, because the only way to get 3 is 3 times 1. So prime number would be 3. 5. 5 times 1 is the only way to get 5, so it's also prime. 7. 7 times 1. Now, it's not just all odd numbers, because if I went to 9, well, I could get 9 going 9 times 1, or I could get 9 by going 3 times 3. So 9 is not a prime number because we can get it going with something other than 1 in itself. So a prime number is a number that can only be found by multiplying by itself and 1. 5, 5 times 1. 7, 7 times 1. So prime factorization is when we write a number as factors, but only factors that are prime. Well, how do we do this? We create a factor tree. Factor tree is something I'm pretty confident you would have looked at back in elementary, and sorry, not elementary, junior high. Back in junior high, you would have done a factor tree. And what it is you want to take every number, in this case 800, and we want to write it as factors. So any 2 factors you want other than 1. Don't write it as a prime number, 1 times 800. That doesn't help us. we could start 2 times 400 because that equals 800. We could do it as 8 times 100 because 8 times 100 is 800. We could do it as 4 times 200. There's lots of possibilities as to what to do. My suggestion is you always want to try to use as big a number as possible that you can think of. Because by choosing the biggest numbers possible, it's going to create a factor tree a lot quicker. So in this case, I like the fact that 800 ends in a 0, and that means we can divide it by 10. So I'm going to say 80 times 10 as my initial factor tree. And from there, every number you create branches, we're going to create branches by factoring each new value. So we're going to take 80 and we're going to factor that. And we're going to take 10 and we're going to factor that. So what do I multiply to get 80? Well, I'm thinking 8 times 10. What do I multiply to get 10? 5 times 2. So from there, I just keep branching down. 8 could be 4 times 2 times 10 could be 5 times 2 times. Now we have 5. But remember, 5 is prime. We showed that at the start. And since 5 is prime, I can't write it as a factored form. I'm just going to leave it as a 5. Same thing with 2. 2 is a prime number also, so I'm just going to leave it as a 2. Well, is there any more factoring to do? Let's take a look. The 4 could be 2 times 2. 2 is a prime number, so I just leave it times 2. 5 is a prime number. 2 is a prime number. 5 is a prime number. 2 is a prime number. So I've now created a multiplication question with only prime numbers. How could you multiply to get 800? 2 times 2 times 2 times 5 times 2 times 5 times 2. There's the prime factorization of 800. Now, the only thing with this is that's a big, long list of factors. We can, if possible, write as powers. Remember, a power is an exponent, base with some exponent. Well, in this case, because I have some factors that happen more than once, I could write this in a power form. We have 1, 2, 3, 4, 5 2's, so I could say that that's 2 exponent 5, which would mean 2 times itself 5 times. 2, 2, 2, 2, and 2. Now, along with that one, we also have a 5 and a 5. How could we write that one? Well, that one could be written as 5 squared. 5 is a base twice. And those two things are being multiplied together. So a better way to write 2 times 2 times 2 times 5 times 2 times 5 times 2 would be 2 exponent 5 times 5 exponent 2. Or, order doesn't really matter, 5 exponent 2 times 2 exponent 5. There's the prime factorization of 800. Now, with that being said, let's try again real quick. Is there another way to do the prime factorization of 800? Well, I'd pause at this point if I were you and give it a try. Here's another way to approach it. What if we only did 2 times 400? Well, still equals 800. So in this case, because 2 is prime, we'll bring it down. 400 could be 40 times 10. I've branched down 2 stays. 400 is 40 times 10. 2 stays as is. What can 40 become? Well, 40 could become 4 times 10 times, and 10 can be 5 times 2. Are there more? Yes, 4 and 10 can still be factored. 2 times 2 times 2 times 5 times 2. And I still have my 5, and my 2 is prime numbers. Well, now I have the prime factorization. What's a better way to write this potentially? Well, let's identify. We have some factors that occur multiple times. Let's identify those. And what's the simplified way to write this with powers? We have 1, 2, 3, 4, 5 2's again. 2 exponent 5. And we have 1, 2 5's, which would be 5 squared. Or, putting in the other order, 5 squared times 2 to the 5 means the same thing. So we really get the exact same thing as we did on the previous screen, just using a different form of the factor tree. So a factor tree has lots of ways to do it, but we get the prime factorized form. Now, from there, we got 2 other little things with this, is greatest common factor and the lowest common multiple. Well, here we go. What's nice with this is it's the same process. Greatest common factor is the biggest common number that we're going to multiply by. The biggest number that multiplies to get, in this case, 12 and 28. Well, this process is what I call upside down division. And what that means is we're looking for common factors. Now, you guys have been warned all year long that you need to know your basic facts. Well, now you're going to need to know them. So with upside down division, what we're doing is we want to find a common factor for these 2 numbers. Well, a common factor that'll divide into 12 and 28, keep it simple, 2 will. So at that point, now we divide. 12 divided by 2 leaves us with 6. 28 divided by 2, half of 28, leaves us with 14. Well, find a common factor again. 6 and 14, we're going to do the same thing. What'll divide into 6 and 14? 2 will again. So 2 into 6, 2 into 14, that's going to leave us with a 3 and a 7. But now I'm left with a 3 and a 7, no common factor. And because there's no common factor, our greatest common factor, the largest value that'll divide into 12 and 28, is I multiply, because these were the common values. So the GCF, or greatest common factor, is 2 times 2, which is 4. And there's how we can find the largest number that will divide into 12 and 28. 4 is the biggest thing that'll divide into 12 and 28. It's your GCF. The greatest amount that will divide into 12 and 28, or that is a multiple to give you 12 and 28. Let's try the GCF with 126 and 144. Well, again, have to have some division skills. Calculators would be helpful. There are parts of these units that you won't be allowed a calculator, so you need to be on top of it. At this point, ends in 6 and 4, so we know we can split them in half and divide by 2. Left with 63 and 72. Well, what's common for 63 and 72? Well, it's not a real easy one, but there is something that'll divide into 63 and 72, and that's 9. Tough one. 9 times stable. Got to know it. 9 goes into 63, leaves you with 7. 9 goes into 72, leaves you with an 8. So now we're left with 7 and 8. And again, no common factor. Now, technically, it's 1. But if I divide by 1, I'm just going to get a 7 and an 8 again. So dividing by 1 does absolutely nothing for us. So because there is no common factor, well, here is our GCF. The biggest number that you can multiply by to get 126 and 144 is 18. There's your GCF. 18, the biggest number that you can multiply to get 126 and 144. Now, the second thing here, besides greatest common factor, is the lowest common multiple. This is the smallest number that 20 and 25 will produce. So instead of finding the things that we multiply to get these, we want to know what's the smallest thing that 20 and 25 will produce. Well, the great thing is it's upside down division again. So we're going to do upside down division again. So with upside down division in this case, let's give myself some room over here. What's going to divide into 20 and 25? Well, 5 will. 20 divided by 25 is 4. 25 divided by 5 leaves me with a 5. Again, no common factor. But here's the big change, is the lowest common multiple, instead of just looking at the 5 here and the factors, well, the lowest common multiple, we have to multiply the L. So the lowest common multiple is going to be all of this. 5 times 4 times 5. And that works out to be 100. 100 is the smallest number that 20 and 25 can both become. Smallest one. It's the lowest common multiple. So the last one, try this example. And again, a little bit of a difference with this one. 3 numbers. So what's the common multiple? We want to identify a common multiple for all terms to start. So 12, 9, 24. Basic facts, got to know them. 3 will work. 3 goes into 12, leaves us with 4. 3 goes into 9, leaves us with 3. 3 goes into 24, leaves us with 8. So at that point, there was our common multiple. There's no common multiple now. But with 3 or more terms, we only have to divide into 2 of the terms. This is a really important thing to remember for lowest common multiple. If there's not a common multiple for everything, we only have to be able to divide into 2 of the terms. So in this case, I can now divide 4 and 8 by a 2. So 2 goes into 4, leaves us with 2. 2 goes into 8, leaves us with 4. And the 3 just comes down. Is there anything else? Well, we can see that 2 and 4, common multiple, we can reduce by 2 again. 2 goes into 2 once. 2 goes into 4 twice. And the 3 is just brought down. So the lowest common multiple in this case, again, we multiply the L. And the lowest common multiple would be 3 times 2 times 2 times 1 times 3 times 2, and that will be 72. The lowest common multiple of 12, 9, and 24 after all is said and done is 72. LCM, 72. 12 can become 72 times 6. 9 can become 72 times 8. 24 can become 72 times 3. So there's your first lesson. Doesn't have anything to do with polynomials yet, but it's a whole bunch of work to deal with factors, products, and multiples. There's your assignment, bottom of page 4. In the booklet, page 4, number 1, 2, 3. And the textbook, page 140, number 3 to 6, 8 to 11. Can't stress enough, 2 things: know your facts. That's important. You need to know your times table. I know I only suggested it a million times up until now. Well, here's reality. And the second thing, the only way to get good with this stuff is practice. You're not in school. You don't have now me to say for 40 minutes, get to work, you need to practice. Now you just got to do it.